Imagine a world where energy is virtually limitless, clean, and astonishingly cheap, powered by a reaction that can happen right on your kitchen counter. What if scientists announced they had achieved such a breakthrough, promising to change the world forever? The cold fusion media frenzy was dramatically sparked in March 1989 by two chemists, Stanley Pons and Martin Fleischmann, who announced at a press conference that they had achieved nuclear fusion at room temperature. This sensational claim, made without prior peer review or publication, immediately captured global headlines and ignited a wildfire of excitement and controversy. This announcement generated such intense interest because nuclear fusion is typically the domain of stars and requires temperatures of millions of degrees Celsius, a process known as hot fusion. The idea of achieving fusion in a simple tabletop experiment, using readily available materials like heavy water and palladium, promised an energy revolution that would bypass immense engineering and cost challenges. The scientific community was both intrigued by the potential and skeptical of the unconventional announcement method, while the public eagerly embraced the vision of abundant, clean energy. For scientists, the initial challenge was attempting to replicate the Pons and Fleischmann experiment, which involved running an electric current through palladium electrodes immersed in heavy water. Many research groups worldwide rushed to duplicate the setup, carefully monitoring for signs of excess heat, helium-4 and neutrons, which are expected byproducts of fusion. This surge of experimental activity, while ultimately inconclusive, became a crucial part of the story, highlighting the scientific method's emphasis on independent verification. The core of the cold fusion claim centered on the idea that deuterium nuclei, isotopes of hydrogen found in heavy water, could be packed so tightly within a palladium lattice that they would overcome their natural electromagnetic repulsion and fuse. This theoretical concept, known as lattice confinement fusion, was proposed as the mechanism for the supposed low-temperature reaction. However, most mainstream physicists quickly pointed out that the energies involved were far too low to initiate fusion, leading to the rapid scientific discrediting of the claims. The media, having initially amplified the excitement, also played a role in reporting the subsequent failures to replicate the results. The enduring legacy of the cold fusion media frenzy lies in its powerful illustration of how scientific discovery, public hope, and media attention can intertwine. It showed the profound impact of dramatic claims on both scientific research and public perception, underscoring the vital importance of rigorous peer review and consistent, verifiable evidence before new scientific paradigms can truly take hold and transform our world.